So hello guys, welcome back again, and today we want to talk about disaccharides. Yeah, still carbohydrates. Disaccharides. Yeah, so remember, as we said last time when we were talking about monosaccharides, we said that monosaccharides are simple sugars. They are only made of one simple sugar. And now di, as you know, means two. So di is made up of two simple sugars. Di means two, then saccharide means sugar. So just to maybe start on, we all know the formula for carbohydrate, which we said is a CH2O in bracket N, whereby N represents the number of carbon atoms. And because glucose is a hexose, they have, because carbohydrates are hexose, they have 6 carbon atoms. So this will give us C6H12, then O also we are going to have 6. So this one is the formula for glucose. So this N is 6, don't forget that. So we move on. So we want to know the disaccharides that we are having, so that we can be able to know how they are formed one by one. So we have number one, we have lactose. Number two, we have maltose. Then number three, we have sucrose. Number three, we have sucrose. So maybe just to start on, let's start with sucrose. Let's start with sucrose. So number one, sucrose. Number one is sucrose. I'm using my hand, so it's a bit hectic to write here. Yeah, so it's sucrose, and the formula, just as we have written it up here. So sucrose is made up of two simple sugars. Let me show you using the formula. So two simple sugars. Number one is so they all come together to form sucrose, which is now going to be let me show you the process how they form. Yeah, so C6H12O6 plus C6H12 O6. So all these, when they come together through a process known as dehydration, okay, dehydration, we are removing a molecule of water, or otherwise this process is also known as whatever will be formed will be a glycosidic bond, will have a glycosidic bond at the end. So when we combine these two, the CH, these are simple sugar here, and this simple sugar, we are going to get a disaccharide. And through the process of dehydration that we've written here, we are going to lose a molecule of water. We are going to lose water in all this process. We are going to lose water. Then at the end, what we are going to have will be, if you combine these two, you dehydrate through the process of it will be dehydrated. Yeah, in other words, it will be dehydrated, as we will lose a molecule of water, and then whatever we are going to have at the end will be we are going to have C will remain. So we are going to have C12, the first C plus the second C, 6, that's going to be 12. Then H, remember we've lost 2 molecules of hydrogen, so 2 atoms. Yeah, we've lost 2 hydrogens, so C12, H here is 12 and the other side here is also 12, so that's supposed to be 24, but because we lose 2, we are going to have H to be 22. Then O, we are going to have 6 O's plus 6 O's, that's going to be O12, but because we have lost only an atom of oxygen, sorry, so we are going to have 12 minus 1 and we are going to have 11. So whatever we have formed here, this one is a disaccharide. This one here is a disaccharide, and you can reverse this process as well. And how do you reverse this process? Yeah, through hydrolysis. C12 H22 O11 through hydrolysis. Yeah, through hydrolysis, or the presence of the enzyme of that particular disaccharides. For example, if it's maltose, the enzyme will be maltase, and therefore maltase will be able to hydrolyze these disaccharides to 2 simple sugars. So when we hydrolyze this one here, we are going to have remember, when we are hydrolyzing, we are adding a molecule of water, and when we add a molecule of water, we are going to end up having these 2 here. We are going to have these 2 individuals. Yeah, so I hope up to that point everything is home and clear. So let's just go ahead and see how sucrose structure is formed. So sucrose is the normal table sugar. It's the sweetest, and it's what you normally put in your tea, or rather maybe you taking water and you find that it's not tasting nice and you just want to add some sugar. So the sugar that you are adding there, that is sucrose. And for you to form sucrose, you are going to have 2 molecules of simple sugars. Yeah, so the sugars that make up sucrose are alpha glucose. Let me write in black. Is alpha glucose plus beta fructose. So these 2 simple sugars are the one that make sucrose. So let's draw. Remember, when during the last time when we were talking about disaccharides, I told you that when you want to memorize this structure correctly, draw the Fisher projection, or rather the let me just say the Fisher projection at the back of your head, or just have it beside your work as a rough work, so that you are able to replace the Fisher projection and the cyclic whenever you are now inserting the OH and the H correctly. So for alpha glucose, remember, when you say alpha, you know that the hydroxyl group should be down, yeah, not the other way around. So to draw let's draw the structure for alpha glucose. Yeah, so that's the structure for cyclic form for glucose, which is a 6-membered ring, and as you can see the sides, there are 1, 2, 3, 4, 5 and 6. Now because our glucose is alpha, we are going to let's start replacing them. We are going to put this one here, And for alpha should be down, so we are going to have our OH down here, and we are going to have our H up here. Yeah. So after that, for glucose, carbon number 2, we always have OH to the right, so we have OH down here, then we have H here, then at carbon number 4 we always have OH here, and carbon number 5 we have, because during that process when we are forming the cyclic, there was some changes here and the OH went here, so down here we are going to have H, and up here we are going to have CH2OH, just as usual. Then we want to combine these alpha glucose to fructose so that we can form a sucrose. So to draw a fructose, it's very simple. What you're going to do is put the oxygen up here. After putting that oxygen, draw a 5-sided structure. Draw a 5-sided structure, and make this one here to be the anomeric carbon, and it's always carbon number 2. For glucose here now, anomeric carbon remains to be carbon number 1. And because our fructose up here was bitter, we are going to have the OH. We are going to have the OH up here. Yeah, and down here we are going to have the CH2OH, which is now acting as the first carbon. The second carbon is the anomeric carbon. Then also this side we are going to have CH2OH up here. Remember, in fructose we always have 2 COH, 2 OH. We always have CH2OH times 2. Yeah, so down here now let's start replacing them. Remember, at carbon number 3 it follows the same as what is in glucose. So in glucose at carbon number 3, 1, 2, 3, we had the H here. Then down at number 4 we had OH, and at number 5 it follows what is supposed to be the same in glucose. So glucose, this was number 1, number 2, number 3, number 4, number 5, but this is the cyclic form for glucose. When you draw Fisher projection for glucose, yeah, draw a Fisher projection for glucose. Draw a Fisher projection, and that is 1, 2, 3, 4, 5, then 6, the CH2OH here. The first one is always the OH, here is H, then here we are having OH, here we are having OH, here we are having H, here we are having H, here we are having H, and also here we are having H. And we said whatever is on the right, we say that whatever is on the right, you take them down, yeah, down of the stick, and whatever is on the left, you take them up of that stick. Yeah, so if here is carbon, at plus here, up is here, then down is here. So whatever is to the left, we take them up. So I hope that one is also clear. So at our carbon number 5, this is carbon number 2, carbon number 3, carbon number 4, carbon number 5. So carbon number 5, out to the right, we take it down, and it's OH. It is OH. And now we can start replacing the H inside here. Here we are having the OH, and also up here we are having H, we are having OH here, here we are having H. So now let's form our bond. To form our bond, these two, let me highlight them. These two here, these two hydroxyl groups, they will form a water molecule. Yeah, and that water molecule, because it's being taken away, it will be a process of dehydration, and during that process of dehydration we are going to form a glycosidic O bond. We are going to form a glycosidic O bond. So the bond that we form here, when we take out these two, so we can delete them after highlighting them. I hope you are getting that very correctly. Hope you are getting that very correctly. So we can delete these ones. Can delete these ones here. Yeah, so let's delete them, and also delete this one. So the bond that you are going to form here, it will be a straight stick. Let's make it to be straight now. So the bond that you are going to form here, let me break it. So you are going to have, here O, then you combine these two. So the O here is the glycosidic bond that is now combining the two monosaccharides to form the disaccharide, and it's always the first anomeric carbon of the alpha. So we are going to have the first anomeric carbon of the alpha, so it's alpha 1, and we are going to see what we are having with the fructose down here. It's the anomeric carbon number 2. So it was alpha 1 and beta 2 glycosidic bond. So that's exactly how fructose combines with glucose to form sucrose. Yeah, 1,2 glycosidic bond, and that one is here. Anomeric carbon for glucose, we are having it here, alpha. So it was a alpha, and it's anomeric carbon number 1. Then also here for fructose, we are having it at carbon number 2, and it was a beta fructose, so it's going to be here. And that's how we've ended up with we've ended up with alpha 1 beta 2 glycosidic bond, yeah, glycosidic, not glucosidic. So that's particularly how that one is formed. I'm doing this while at work. Yeah, so as we have said, there are these two here, these two. Yeah, so this one combines these two. Yeah, these two, this structure here, they combine, and this is the O bond. Yeah, glycosidic O bond is formed due to the process of hydration. During hydration, water molecule is taken out. When the water molecule is taken out, that is what happens, and that's how we had this formula. That's how we had this formula, CH22O11, because we are now lacking water in it. But if you add water here, we are going to have C12H, we are going to have 24, and oxygen we are going to have 12. So I hope that is very clear. And now let's move to another sugar. Let's now do something on maltose. Maltose. So number 2, we are having maltose. The formula is the same. So maltose is also a disaccharide, and the formula remains C12H22O11. yeah, because it has been dehydrated. So if you hydrate it, you're going to get the individual sugars that made up these sugar. So I forgot to mention something here, by the way. I forgot to mention something here. So during when you are reverting, or rather when you are reversing from this one to this one, yeah, there is this water molecule that makes it hydrated. So that water, through the help of an enzyme. So remember here we were dealing with sucrose. So the enzyme that will act here from sucrose to form a simple sugar is an enzyme sucrase. Yeah, to form a simple sugar. Yeah, so here we are going to have water. I hope that is clear. So let's do something on maltose. Yeah. So maltose, still the same. There is no difference. So let's draw the. Yeah. So for maltose, we have two simple sugars, and they are always glucose and glucose. So we have, and the glucose that always make that, they are alpha glucose. Cut it short. So let me configure my lights and we go on. So number two, we are supposed to talk about maltose, and we said maltose is also made up of two simple sugars, which is glucose plus glucose, and the glucose that are responsible for these are alpha glucose. Yeah, so alpha glucose plus alpha glucose, we are going to get through the process of dehydration, or rather O glycosidic bond, we are going to have a sucrose. Sorry, not sucrose, but maltose. We are talking about maltose now. We're going to have maltose, which the formula is here. Yeah. And when you want to now break down these maltose back to these two, you're going to have an enzyme known as enzyme maltase, which will hydrolyze this one, it will be hydrolyzed. Yeah, so when maltose is hydrolyzed using this enzyme maltase, it's going to be back to two individual sugars, which are alpha glucose and alpha glucose. So let's see how its ring is formed. How glucose. So here we're going to have our cyclic structure, and also this side we are going to have our cyclic structure. Yeah, and remember they are alpha glucose. Also this side is alpha glucose. So when you hear alpha glucose, when you hear the word alpha, just know that the OH is down. Yeah, so this is carbon number one here, and alpha, the OH is going to be down. Also this one is alpha, the OH is going to be down. So this one here is our carbon number one, this one is our carbon number one. Don't confuse. carbon number 1, and this one is carbon number 4. This one, this side is carbon number 4. So let's replace them here, these ones. Yeah, this one is CH2OH, don't forget that one. This one is also CH2OH. CH2OH. Carbon number 1 here, then carbon number 2 we always have OH for glucose. Carbon number 3 we have H. Carbon number 4 we have OH. And up here, like I said, up here we are going to have H. Here we are going to have H because of that alteration of the carbon number 5. So this one is also glucose, so we are going to have the same OH, H, OH, H, H, OH, H, OH, H. So when you combine these two, yeah, how does these two form? So these two, let me put a plus here. Yeah, so when you combine these two, they are going to lose a molecule of water, H2O, and that will be like dehydration. So that one is going to affect these two. It's going to affect these two. Let me just delete them. It's going to affect these two, this one here. It's going to affect this one, and it's going to affect this one as well. So whatever we are going to have here is going to be this one, yeah, with a release of water. So water has been released, and now we are having a O-glycosidic bond. Yeah, we are having O-glycosidic bonds, but we have to mention the position of the carbons. So this one is carbon number 1 and carbon number 4. So we are going to have alpha 1, alpha 4 glycosidic bond. So this is how the maltose is formed. 2 alpha glucose combining through the process of dehydration, and we are going to have a glycosidic bond, thereby we will be resulting with this kind of structure. Yeah, this is the final structure for maltose. Let's do for lactose. So maltose is present in malt. It's a malt sugar. Those who are taking Guinness, yeah, so Guinness has it, beer has it, yeah, so that one. Number 3, let's see lactose. Lactose is a milk, is present in milk, so it's a sugar that is present in milk. So at one point you had somebody say that I have lactose intolerance. So those are those people who, when they take milk, they start having a problem with their stomach will start crumbling because they have lactose intolerance. So lactose is a sugar that is present in milk, and to break down lactose you have to have that enzyme known as, let me write in black, that enzyme known as lactase, to break down lactose into individual sugars. So just as I did to those other ones, nothing different. So for lactose, it's also 2 sugars, and it's always beta galactose plus alpha glucose. So when you combine these two, you are going to have lactose, and the process is dehydration. Yeah, the process is dehydration, whereby water molecule will be released. out. So that easy. Let's draw the structure, or rather let's see how these glycosidic bond for lactose is formed. So we have this one here, yeah, so that one plus, so galactose is also a 6-sided ring. Galactose is also a 6-sided ring. Galactose is also a 6-sided ring. In other words, it's a pyranose. So when you combine these two, okay, let's replace the sugars first so that we don't miss them out. So we are going to have CH2. Hello, how are you? So up here we are going to have CH2OH, just like in glucose. CH2OH, and because it's an alpha sugar, the OH is going to be down here. We are going to have H here, and down here we are going to have OH, we are going to have H, OH, and here also we are going to have H. So that one is for alpha glucose, and this other side we are having beta. We are having beta galactose. So the difference between galactose and glucose is at carbon number 4. So carbon number 4 we are having OH here. For galactose we are going to have OH up. So for galactose, just draw that one first so that you don't forget. Yeah, and it's a beta galactose, so OH is going to be up here and H is going to be down. Carbon number 2, it's the same with glucose, so it's going to be OH. Here we are going to have H, here we are going to have H, here OH, here we are going to have H, here we are going to have CH2OH, and down here we are going to have H, same here, H, OH, H. So we are done with that, but now they are a bit different. You see where the OH is. The OH is up here, yeah, and this one is down, simply because we are having a beta galactose, and alpha glucose. And as you know, at carbon number 4 they are always different, yeah, they arrange differently. So our interest here is going to be on how we can remove this one. So let's select this one, OH, delete it, and also the OH that is down here, also remove it, yeah, the OH. So when you combine the two, the bond that is going to be formed will be something of this sort, yeah, so it will be like this. Okay, let me not complete it, let me write the O in the middle here first, the O in the middle there. Now we can proceed. So we are going to have, this is the type of bond that is going to be formed. So you can see the O glycosidic in here, and water has been released. Water has been released. So this one here is because galactose, the anomeric carbon is carbon. This is the anomeric carbon, and it's combining with the it's combining with the carbon number 4 of the alpha glucose. So we are going to have 1 beta. We are going to have 1 beta and 4 alpha. 4 alpha glycosidic bond. So how easy was that? Hopefully it was. So for galactose, for lactose also, to revert it to its simple sugars, you're going to use an enzyme known as enzyme lactase to hydrolyze lactose back to glucose and galactose. Yeah, so basically that's all. Yeah, that's all. There is nothing left. So in case you have any question, maybe you can ask in the comment section. Yeah, so see you again in the next one when we'll be doing something different. See you. Peace out.